Hello, welcome everyone. In this video, we're going to discuss the solution to MOTS 2022. It's a Olympiad talent search examination conducted for 6th grade and 7th grade students. In case you have not taken this test, I strongly encourage you to go online, www.matholympiadonline.com. And this is a free test that you can take. 30 minutes to complete 20 questions. These are really good quality questions. And here we're going to discuss the solution to these problems. All right. Now, please pause the video in case you have not taken the test. Go ahead, take the test, and then come back to this video. And for those who have already solved these problems, here are the solutions. Okay, let's move ahead. All right. So here are the questions. There are 20 questions in total. We will solve them one by one. The first question: how many of the following statements are true? Now, there are 4 statements here. We have to find out how many of them are true. All right. Now, if you look at this, a prime number multiplied by a prime number is always prime. Is that a true statement? You have a prime number, P, is multiplied by a prime, let's say Q. Now, this is prime, and this Q is also prime. Will this product be a prime? Let's say it is equal to n is equal to p into q. Can n be prime? Of course not, isn't it? Because you have p and you have q. There are 2 numbers multiplied with each other, and that is giving us n. That means n has factors p and q. P and q neither can be 1 because they are prime. 1 is neither prime nor composite. That means p and q are not equal to 1. They are some prime numbers. And so n has 2 factors, p and q, at least. So that means n cannot be prime. So the first statement is false. How about the second one? A square multiplied by a square is always a square. Okay, let's take a square number. We can take some example. Let's say 5 square. This is a square number, isn't it? 25 is a square number. Multiplied by another square number. Let's take 3, for example. 3 square. So this is a square number. This is a square number. 3 square. So we have taken 2 square numbers and multiplied them together. Now the question is, can this answer always be a square? How do we find this out? You have 5 square times 3 square. You notice that the exponent is the same for both of them. And so you can actually combine them as 5 times 3 the whole square. Isn't it? This 5 times 3 the whole square is same as 5 square times 3 square. The squaring applies to both the numbers when they are in multiplication. So now you get 15 square. Now notice that this is definitely a square number because it is 15 square after all. Now we have taken a specific example 5 and 3, but this can be done for any number in general. So you don't have to assume specific number. That is just for ease of checking whether it is true or not. So any number, let's say a and b, if you take a square times b square, that can be written as a times b the whole square. And so this is definitely a square number. So the second statement is true. So we have the first statement is false. The second statement is true. How about the third one? An odd number multiplied by an odd number is always an odd. So odd times odd. Is this always going to be an odd? Can we check it? Again, give a simple example. Like odd number, let's take 5, and another odd number, let's take 3. 5 times 3 is equal to 15, right? So it is an odd number. The answer is also an odd number. You cannot get an even by multiplying 2 odd numbers together. All right. So that third statement is also true. How about the last one? An even number multiplied by an even number is always an even number. E times E is an even number, and here is another even number. Again, we can give examples. 2 times 4 is equal to 8. It's always going to be an even number. So this is also true. So we have 3 true statements and 1 false statement. So the answer must be D, which is 3. So that is the answer for this. All right. So it's a straightforward question. We just have to know some properties about numbers. All right. Let's go. Let's scroll down maybe. And all right. Let's go to the second question. B is a digit in the product shown. What is the value of B? B2 times 7B. They have given the product as 6396. Right. What is the possible value for B? That is the question. It's super easy because you see here there is 2 and you have the B here. So in your regular multiplication, you do this number B times 2, you should be getting 6, isn't it? The 6 must be due to this B times 2. It may be a 2-digit number, but the units place will definitely come here. So that means B times 2 ends in 6. B times 2 ends in 6. That means the unit place is 6. What is the possible value for B? You can have it as 3 because 3 times 2 is 6. Or is there any other possibility for B? Of course, you can also have 8, right? 8 times 2 ends in 6. It's actually 16, it ends in 6, so that's also possible. So all you have is 2 choices, like 3 or 8. We just have to plug it in and see which one works. It's as simple as that. So let's try 3 here, and then this also becomes 3. 3 2s are 6. Let me do that here. 32 times 73. 6. And then you can do the multiplication the way you do it. I just use a shorthand method. 3 3s are 9, 7 2s are 14. 14 plus 9 is 23. So 3 carry over is 2, 7 3s are 21, 22, 23. So this is the answer for B equal to 3, but that is not the answer that they have given. So that means obviously B has to be 8. So we can go ahead and say the answer is E, which is 8. Just to be more sure, we can just do it, but you don't have to really do it in the exam because there are only 2 possibilities. Let's try it out just for the fun of it. So 82 times 78. 8 2s are 16, carry over 1. 8 8 are 64. 7 2s are 14. 64, 74, 76, 77. 1, 64, 65, 79. So 9, 7, 7 8s are 56, 63. Yes, it is. The answer is 6396. So the correct answer is choice E, which is 8. Let's scroll down further. Let's go to the next problem. Problem number 3. The fraction halfway between 1 by 3 and 1 by 5 and 1 by 3 on the number line. Alright, so you have a number line, you have a number 1 by 5 here, you have a number 1 by 3 here, right? These are fractions. They're asking us to find out what is the one that is exactly in between. Not somewhere in between, but exactly in between. Okay, so how do we find this out? Now, we know that if you have a number line and you have a number here called 1 by 10, and then you have a number here called 3 by 10. Okay, now what is exactly in between? It's easy to say, isn't it? Because this is 1 by 10 and this is 3 by 10. The one in between will be 2 by 10. That is super easy. The reason why it is easy is because you have the denominator all the same, 1 by 10 and 3 by 10. So you just have to look at the numerator and you see that there is a gap. The number between 1 and 3 is 2. So the answer is 2 by 10. However, here in this question, we don't have the same denominator, right? So we can make the denominator same. That's possible because fractions, there is no unique fraction. We can always multiply the fraction, numerator and denominator, and get different values for the numerator and denominator. Let's do that. How to get the denominator the same? That is the question. You can take an LCM or multiply these two numbers to each other. So here 5 and 3, the LCM is 15. So I'm going to make this 15. So how do I do that? I have to multiply this 5 by 3. To not change this fraction itself, I have to multiply the numerator also by 3. So I can make it 1 into 3 by 5 into 3. I have not changed the value, but I have just made the denominator equal to 15. Same thing here, I have to make the denominator 15. I have to multiply the numerator and denominator by 5. Right. So this gives us 3 by 15 and this gives us 5 by 15. Now it has become easy. The denominator is the same and the numerator has 3 and 5. What is the number exactly in between 3 and 5? Yes, that is 4 by 50. So that's our answer. The choice is C, 4 by 50. All right. Now, just a side note, if you have been given two fractions, if you want to just find out some fraction which is somewhere in between, not exactly in between, but somewhere in between, there is a little nice trick there. Let's say the two numbers are a by b and c by d. Okay, this is one fraction and this is another fraction on the number line. You want to find some number in between, somewhere in between, not exactly in the middle. You can simply add the numerators and you can add the denominators. So this number here will be definitely somewhere in between. We don't know where it will be, but it will be somewhere in between. That's a nice property of fractions, right? You have two fractions. You want to find something in between, just add the numerator and just add the denominator and make a new fraction. That will always be in between. Now, interesting thing, let's say we take the number 2 by 4 and this number, say 4 by 8. This is one fraction, this is another fraction. In fact, if you notice, these two fractions are the same. 2 by 4 and 4 by 8, they both actually represent the same fraction value, 1 by 2, isn't it? Now let's try apply this concept. You add the numerator and divide by the sum of the denominator. 2 plus 4 is 6, 4 plus 8 is 12. So this one should be somewhere in between. But these two numbers are the same. There is nothing in between them. They are just one and the same number on the number line. So then that means this also must be the same number. And it is indeed, because 6 by 12 is 1 by 2. 2 by 4 is also 1 by 2. 4 by 8 is also 1 by 2. Right? So they're all one and the same. They're all the same fraction 1 by 2. But if the fractions were to be different, then you can use this idea to get something in between, but not exactly in between. All right. So in this problem, they wanted us to find out something exactly in between. So we use the idea of making the denominator the same. All right. Let's go to the next one. Problem number 4. All right. So here, this is a negative arithmetic problem. All we need to do is be very, very attentive when we try to do problems like this. It's just demanding your attention. That's all, nothing more than that. You know the rules, you know how the arithmetic works, but you have to be very careful with the brackets and do the arithmetic very, very carefully. That's all it's required to solve this kind of a problem. Now let's work it out. Let's take a different color. Let's take this one. So what is minus 2 minus 2? Minus 2 minus 2, both the numbers are negative. So you can simply add them and put a negative sign, minus 4. All right. It is not actually a subtraction problem, it's an addition problem. Minus 2 minus 2, both the numbers are negative on the same side of the number line with respect to 0. So you just add them and put a minus in. Now you see there is a minus here and then there is a bracket. That means minus of this, minus of minus 4. What is that? That is 4, isn't it? Negative of negative is positive. So that is 4. Now we have minus 2. This is plus 4. What is minus 2 plus 4? This whole thing is minus 2 plus 4. That is plus 2. Now you have a minus here. So minus 2. So what you have here is minus of 2. All right, let's do this one. Minus 2 minus 2. Again, this is actually an addition with a minus sign in the front. Minus 4. Okay, now what is this? Minus of minus 4. That is 4. So you have 2. This minus of minus is plus 4. And then you have a minus 2. So the answer is 4. So the choice would be, it is C, 4. That is the answer. Very straightforward, but you have to be very careful in doing this problem. All right, let's go look at the 5th problem. Okay, let's read this question first. Abhinesh's birthday cake is in the form of 4 by 4 by 4 inch cube. The cake has icing on the top and the 4 side faces and no icing on the bottom. Of course, icing on the bottom doesn't make sense. It's touching the bottom. You cannot ice there. Okay, so the cake is fully covered with icing on the top and all the 4 sides of the cube. All right. Now this cake is cut into 64 smaller cubes, each measuring 1 by 1 by 1 inch, as shown below. How many of the small pieces will have icing on exactly 2 sides? It's a very interesting problem. Okay, so let's try to work this out. Let me grab this image so that I can mark on this. Let's take this image and put it over here. All right. Let's zoom in a little bit. Okay, very nice. Now, imagine that this is a cake and you have icing all over, right? On all the sides, everywhere except the bottom. Okay, now it is cut into all these small cubes that are shown with the solid lines here. Now, it is just a logical question. You have to identify those pieces that will have icing on exactly two sides. Okay, for example, if you take this corner piece, it's going to have icing on this side, it's going to have icing on this side, it's going to have icing on the top. So it has icing on three sides. So this is not one of the pieces that we are looking for. All right, so let's not count this. Now, which one can you identify one of the cubes, the smaller cubes, that will have icing only on two sides? Yes, so look at this one here. There is icing here and there is icing here, right? So only two sides of this cube is going to have icing. So this is one valid small cube that's going to have icing exactly on two sides. It's not difficult to find out that this is also going to be a similar small cube having icing on two sides. And so you have to now have your visualization skill turned on to see that this and this are also going to have icing on two sides, the top and the one which is hidden from view, the back side of this cube. All right. Now, how about this and this? By symmetry, this also should have icing on two sides and also this. So you have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cubes from the top row which are having icing exactly on two sides. Now, can we identify more? Yes, we can. So here you see this one. This has icing on two sides. Similarly, this has icing on two sides. Now, again, by symmetry, we can say there should be two pieces here. This side of this cube has icing. The one which is the back side of this cube, which we cannot see, that will also have icing. So two sides of these smaller cubes have icing. Same way, you have this and this. And that corner of the cube, which is well hidden from our view, will have a similar two pieces like this, right, which is in the back side. We cannot see it from here. Those are the extra two pieces that will also have icing, which is completely hidden from our view. All right, is that all, or do we have more? How about this one here? This one has icing only on one side. The bottom doesn't have icing, so this will not be counted. It doesn't have icing on two sides, so let me not count this. What else? Do we have anything more? Yes, we do. You see this one, this has two sides. The top corner did not account for two sides because it has three sides it gets icing, whereas the bottom corner is getting counted because the bottom itself doesn't have the icing. So it has only two sides that are having the icing. So this is going to be one of the valid cubes having two sides of icing. This also is a similar one. You also have here this corner, and again that corner which is at the bottom and hidden from our view, that also has an icing. Now if you just have to count all these ticks, 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the answer is 20. D20. Okay, this is a very good problem that tests our visualization skill. All right, next problem. A pyramid figure is made of alternating black and white squares in each row. Rows 1 to 4 are shown. All rows begin and end with white square. The number of black squares in the 37th row. All right. So here it is a test of pattern, how well we can recognize the pattern. They say that every row begins and ends with a white square. So the pattern is going to continue. Now let's try again, capture this image and then play with it. Okay. Now just to see how the next one is going to look like, we can draw that. It's going to have one cube here, and it's going to have one cube here, or actually a square, I'd say, and it's going to have all these squares. So this is how the next row is going to look like, and it begins and ends with white. So that means this is going to be black, this is going to be black, this is going to be black, this is going to be black. Okay, now do we see a pattern here? This is row 1, How many black do we have? 0 black. This is row 2. We have 1 black. This is row 3. We have 2 black squares. And this is row 4. We have 3 black squares. And this is row 5, which we created. And this has 4. You see that there is a clear pattern emerging, right? 1, 2, 3, 4, 5 are the rows. 0, 1, 2, 3, 4 are the number of black squares. So if we keep doing this and get to row 37, it is going to have 36 black squares, keeping that same pattern. So the answer is C, 36. It's again a straightforward question testing our ability to see patterns and extrapolate them. All right, 7th question. Okay, this is a problem in graph. You have to find out how many routes are possible from m to n. All right, let's again grab this image and work with it. Okay, there are many ways to do this. We can do a brute force, just see how many ways you can get from m to n without missing any valid path. That is one way to solve this. Other ways to see, once you get to some point B, how many ways from B can you get to n? You know, from m to n, you can get through B, or you can get through A. Right? So now you can find out how many ways are there to go from B to n. It's like recursively solving a smaller problem of the same type. Instead of deciding to find out from m to n how many paths are there, if you find from B to n how many paths and then from A to n how many paths, maybe you can add them up. So here from B to n there is one path here, there is another path here 2, and then there is one more 3, and there is a 4th path as well here. So there are 4 paths that you can take from B to n. How many paths can you take from A to n? You can take a path this way, this is 1, and you can take another path here 2. So there are 2 ways you can go from A to n, and there are 4 ways you can go from B to n. So from m you can get to A in one way, and you can get to B in another way. So once you get to A and B, you have 2 plus 4, there are 6 total paths. So the answer is E, 6. All right. Problem number 8. Okay, interesting problem in number theory. When Shruti divides her favorite number by 7, she gets a remainder of 5. What will the remainder be if she multiplies her favorite number by 5 and then divides it by 7? Oh, very interesting problem. So she has some favorite number, we don't know what it is. She divides her favorite number, let's say it is x, that is her favorite number. She divides it by 7, she gets a remainder equal to 5. That means you take x and make it into groups of 7, you will have 5 remaining, isn't it? Let's take x equal to 14 for example, or let's take here it is 19, let's say. Okay, x equal to 19. You divide this by 7. What is the meaning of division by 7? You group it into 7, right? You make it into groups of 7. So you have one group here, 1, 2, 3, 4, 5, 6, 7, and then you have another group 8, 9, 10, 11, 12, 13, 14, and then you have 15, 16, 17, 18, 19. So these are all groups of 7. What is remaining is 5. That is the remainder. Okay, now what is she doing? She is multiplying her favorite number by 5. She is doing x into 5 and then divides by 7. You know, her number has become 5 times more. All right. Now, if her number was x, she is getting a remainder 5. If her number becomes 5 times bigger, then you're going to have 5 such remaining terms, right? You're going to have 1, 2, 3, 4, 5. This is coming out of x. This is coming out of the second x. And then you will get another 5 remainder from the another x If you divide another x by 7, you're going to get another remainder 5, and then one more x, you're going to have remainder 1, 2, 3, 4, 5, isn't it? This is what it means, right? So we said x is her number, and if she divides that by 7, she's going to get a remainder of 5. Now, if this x is repeated 5 times, that is equal to multiplying it by 5, isn't it? X, 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 and x, you get 5x in total. Now, each of these values, when divided by 7, gives you a remainder 5. That means you're going to have all these extra ungrouped terms which are not multiples of 7. It's going to be 5, 5, 5, 5, 5. So 25. If you collect this, you'll get 25 dots. Now, among these 25 dots, you can again put them into groups of 7 because they have become more than 7. So you can take these 25 dots and put them into groups of 7. How would you do that? You would do 1, 2, 3, 4, 5, 6, 7. This is one group. Then 8, 9, 10, 11, 12, 13, 14. This is another group of 7. 15, 16, 17, 18, 19, 20, 21. This is another group of 7. And then you have 4 more left. 22, 23, 24, 25. So the real remainder now will be 4. Alright. So if she takes her number, favorite number, multiplies by 5 and then divides it by 7, she is going to have a remainder of 4. You can also do this problem by taking an example. We took an example x equal to 19, such a way that when x is divided by 5, you get the remainder equal to 5. So x is divided by 7, you get a remainder 5. Now you do 5 times x, 5 times 19, that's equal to 5, 4, 95. So now you divide 95 by 7. 95 by 7, that's equal to 7 ones are, 7 threes are, the remainder is 4. Right? So you can take an example, a specific example, and also work this out, or you can do it also mathematically. It's a nice problem. It involves the concept of reminders. Okay, moving on. So the answer for this previous problem is E, right? That is the answer, E. Choice E, which is 4. Problem number 9. There are 6 squares on which letters P, Q, R, S, T, U are written. It is folded along the dotted lines. Okay, I see the dotted lines here. To form a cube as shown. Oh, basically this is a net and you are forming a cube from using this net. Which letter will show up on the square opposite to the square having T on it? Alright, so this is again a visualization problem. You have to visualize this and see. You can take a paper, make this shape and cut it out, and then you can fold it along these dotted lines and you can actually see for yourself which one comes right across T. And the answer is Q. So if I take this snapshot, put it here. So the one that is going to be opposite to T is Q. The one that is going to be opposite to P is S. And the one that is going to be opposite to R is U. You see, it's more like a knight pattern in chess. If you know how a knight moves, K-N-I-G-H-T, that's a piece in chessboard, it moves in this fashion, like P and S. If you start from P, it will go to S. If you start from Q, it will go to T. So this is the moving pattern for that piece. So you can call it as a knight pattern. But this is pretty much a visualization problem. You have to imagine forming a cube using this net and see what comes right across T. I hope you can do it. If you find it difficult, you can take a piece of paper and cut it out and try it and see it for yourself. Okay, we'll move on to the next problem. Problem number 10. In a parking lot, there are 60 cars, all of which are black or blue, and all of which are either Maruti or Toyota make. There are 25 black Maruti cars, there are 18 blue cars, there are 25 Toyota cars. How many blue Toyotas are there in that parking lot? Okay, there is a lot of information in this question. So if we simply try to keep everything in our head, it might be difficult. If you can do it, that's great. But if you find it difficult, I would do it this way. I will note it down in a certain way so that I can get the answer. So the way I'm going to note it down is, I know that there is either Maruti or Toyota. And the cars are either blue or black. So I'm going to make a table like this. So these are the possibilities, right? It's either a blue car or a black car. It is a Maruti make or Toyota make. Total cars 60. Good. So total is 60. 25 black Maruti cars. So Maruti black. So there are 25 cars in this quadrant. There are 18 blue cars. Okay, so blue cars, all these put together, these are all the blue cars, right? So that is 18. I don't know how many of them are Maruti and how many of them are Toyota. So I'm going to put it right in the middle. The entire blue cars totals to 18. There are 25 Toyota cars. All right. So Toyota cars here, these are the Toyota cars. Again, I don't know how many of them are blue, how many of them are black, but the total Toyota cars given to be 25. How many blue Toyotas are there in the parking lot? They are asking what is this in this quadrant? How many blue Toyota cars are there? Okay, so now how do we find this out? We have been given this total 60. Now you see there are 25 black Maruti cars that is given. And then they have also given there is 18 blue cars and 25 Toyota. Now how do we use this total number of cars and try to figure this out? If you think about it, you have Toyota cars 25. That contains all the Toyota cars, right? Maruti cars, you have 25 which are black in color. So that is 25 plus there is going to be some here, right? We don't know how much that is. But you know that the total Maruti plus Toyota has to be 60 because that is the total number of cars. So if this Toyota cars are 25 and if the Maruti black are 25, they add up to 50, then 10 more cars have to be this blue Maruti. So this must be 10. Isn't it? Total Toyota cars are 25, black Maruti cars are 25, totals up to 50, but there are total 60 cars. That means the blue Maruti cars must be 10. Okay, once you know this is 10, we already have marked the total 18, the total blue cars are 18, out of which Maruti cars are 10, so this must be 8. That's it. So that is our answer, 8. So the blue Toyota cars are 8 in number. The choice is A, 8. All we did in this problem is to mark it very clearly, make a diagram and mark it, and then it becomes straightforward. We use the total also. We know that the total has to be used some way to solve this. So we got the answer. All right, moving on to the next problem. Problem number 11. 100 flowers were kept in 4 vases. After some time, 4, 5, 3 and 8 flowers were taken out from the first, second, third and fourth vase. So let me mark the vases. 1, 2, 3, 4. There are 4 vases. All right. 4, 5, 3 and 8 flowers were taken out from the first, second, third and fourth vase. Now all the 4 vases have the same number of flowers. The number of flowers in the fourth vase at the beginning was a very nice problem. So total 100, right? All these initially had 100. They removed 4 out of this. They removed 5 out of this. They removed 3 out of this and removed 8 out of this. How many flowers did they remove? That is a key idea here. They removed a certain number of flowers from each of them. How many in total were removed? 4 plus 5 plus 3 plus 8, that's equal to 20. So 20 removed. So after removing these 20 flowers, all the flower vases have the same number of flowers. You see, initially you had 800. This is the initial number of flowers all put together. You remove 20, you will have 80. and all of them have the same number. That means you should have 20 here, 20 here, 20 here, 20 here, isn't it? After removing, they all had the same number of flowers. It must be each 20, 20, 20, 20. So the question is asking how many number of flowers in the fourth vase at the beginning. So before removing this 8, it must have had 28, isn't it? 20 plus 8, 28. You remove 8 and then it gets 20. So the answer is 28. That is choice D. It's a very simple problem, but the key idea here is when we remove flowers, we have to find out how many were removed so that you can know what is remaining and then distribute them equally, because the question says each vase now has the same number of flowers. All right, let's go to the 12th problem. Okay, it looks like a problem in algebra. P plus P equal to N, P plus N equal to Q, D equal to Q plus N. What is the value of D by P? So they're asking D over P. How much is that? If you look at the choices, there are no alphabets in the choices. It's a number. So that means if you substitute the values for D and P, they should kind of cancel each other and it becomes a number. That's kind of interesting. Let's see how it happens. We need to find out D by P. Let's start with the numerator D. What can you do for D? D is equal to Q plus N. Let's write that out. Q plus N. And the denominator, I'll keep it as P. Okay. I know that at some point, the numerator and denominator has to cancel because I have to get rid of this P from the denominator, right? Because the answer doesn't have any alphabets, any variables. It's all numbers. Okay. Now, what should I do next? You see, another equation is given. P plus N is equal to Q. So I have Q here. I can substitute for the Q as P plus N. So this Q is substituted with this P plus N. And then I have this plus N divided by P. Okay. Now, I like to keep the P because the denominator also has P. In the numerator, I will keep that P as it is, hoping that it will eventually cancel. But I have N in the numerator. In fact, there are two N's. What should I do with N? Again, there is another equation given. P plus P is equal to N. That means N is equal to 2P, right? So P plus P is equal to N means this is 2P is equal to N, or N is equal to 2P. I'm going to use that here for this N and for this N. I'm going to put 2P. So I will have P, which is this first thing as it is, plus for this N, I'm going to put 2P because that's N is equal to 2P. For this other N, I'm going to put another 2P divided by P. Now this is P plus 2P plus 2P, that's 5P divided by P. 5P by P is nothing but 5, because whatever this P is, it can get cancelled. Of course, P cannot be 0. You cannot divide by 0. The question doesn't say it, but I think we have to make an assumption that P is not equal to 0. So the final answer is 5. Choice B. That is the correct answer. Now, in this problem, we just substituted, and with the thinking that the numerator and denominator should kind of cancel. So we did not keep going back and forth. We went in certain direction so that the numerator and denominator has the same variable P. Right? That's what we did to solve this problem. Okay, let's go to the next problem, problem number 13. A number x has a property such that both x by 2 and 2x are 4-digit whole numbers. What are the 4-digit whole numbers? 1000 is a 4-digit whole number. All the numbers after that up to 9999. These are all 4-digit whole numbers, isn't it? Okay. Now we have to find how many such numbers exist. Such numbers meaning how many numbers like x, which has a property that if you divide by 2, it is still a 4-digit whole number. If you multiply by 2, that is also a whole number. Okay, let's take this multiply by 2 first. 2x should be a 4-digit whole number. 4-digit whole number. See, if you take x, anything more than 5000, if you multiply by 2, it will become 10,000, isn't it? So you cannot take anything more than or equal to 5000. You have to stop at 4999. Because the moment you take 5000, If you multiply it by 2, you're going to get 10,000, which is a 5-digit number. So you cannot go more than this. The x cannot be more than 4,999. Okay, that is one finding from this second part of the question. 2x is a 4-digit whole number. How about x by 2? X by 2 should also be a 4-digit number, right? How is that possible? If you divide a number by 2, it should still be greater than 1000 or greater than or equal to 1000. So that means you cannot go less than 2000, isn't it? If you go less than 2000, it's going to give you a 3-digit number. If you are exactly at 2000, you divide by 2, you're going to exactly get 1000, which is still a 4-digit number. So 2000 is still okay, but anything less than 2000 is not okay. So your answer should be between these two, or in fact all these numbers from 2000 to 4999. Is it true that it is all these numbers from 2000 to 4999? That is a very tricky part to realize. What we are saying is x by 2 is also a 4-digit whole number. Now, if you divide a number by 2, when will it become a whole number? Only if the number x is even number, right? So if you take 2000 and you divide by 2, you get 1000. That is still a 4-digit whole number. If you take 2001 and divide by 2, that is not going to give you a whole number. That's going to give you a fraction. But if you take 2002 and divide by 2, you're going to get 1001. Yes, that is still a 4-digit whole number. That means all even numbers from 2000 all the way to 4999, they are the answers. They are the numbers which have the property that if you divide by 2, as well as if you multiply by 2, they will still give you a 4-digit whole number. So how many even numbers are there from 2000 all the way to 4999? How many numbers are there from 2000 to 4919? This is inclusive, right? 2000 is also included. If you don't include 2000, you will get how many numbers? 3000 numbers, or a little one less than that, right? So you get from 2000, if you start counting all the way up to 4999, you will have 3000 numbers. I'm including 2000 also in that. If I don't include 2000, then I will have 2999 numbers. But because I'm also including 2000, I will get 3000 numbers. Okay. In these 3000 numbers, half of them will be even, half of them will be odd, isn't it? Because for every even, there is an odd sitting next to it. And you are starting with even and you are ending with odd. So if you take the first number as even, the next number is going to be odd. Again, the next number is even, odd, and it finally ends in odd. So that means half of these numbers are going to be even numbers. So the answer is 1500. Choice is B, 1500. Okay. The only tricky part here is once you found the range, you have to realize that it's only the even numbers that will satisfy the property, because we are dividing by 2 and we should still get a whole number as the answer. Okay. All right, 14th problem. There are 3 prime numbers p, q and r whose sum p plus q plus r equal to 22. Find the largest possible value for p times q times r. It's an excellent problem here. Now this again is a number theory problem. There are 3 prime numbers. 3 prime numbers. There's a reason they have said 3 prime numbers. They add to 22. Now you know the properties of prime numbers. They are mostly odd except 2, right? 2 is the only even prime number. Otherwise, if you leave 2 out, it is all odd numbers. Let's, for the time being, let's say these prime numbers are all odd. Okay, so that means odd plus odd plus odd. If you take 3 prime numbers which are odd and add them up, will the answer be even or odd? You first do this, odd plus odd, that's going to give you even. Now you add even and odd, that is going to give you odd. Right? So the answer is going to be odd. But it is given that they all add up to 22. That is even. So this means the prime numbers are not all odd. There must be one even prime number. And the only even prime number is 2. So that means your prime numbers are 2, something comma something. We don't know what the other two prime numbers are. But this is the only way you can add up 3 prime numbers to get an even number. Otherwise, it's going to give you odd. All cannot be odd. So there has to be one even, and the only even prime number is 2. So we have solved half of the problem. Now the sum is going to be equal to 22. That means these two should add up to 20. What are the two prime numbers when you add them can give you 20? This you can do it in trial and error. You know the prime number 3 and 17. They will add up to 20. Or you can have a prime number 7 plus 30 that also adds up to 20. Right? Now these are the two possibilities we have. So the prime numbers can be 2, 3, 17, or they can be 2, 7 and 30. Now among these two possibilities, which one will give you the maximum value, the largest possible value for the product? So then you have to check 2 times 3 times 17 versus 2 times 7 times 30. You can do that multiplication. That is, the top one is 6 into 17, 402. The bottom one is 13 times 14. That is 2, 1, 5, 8, 182. Among these two, 102 and 182, 182 is the largest possible product. So we will go with the answer 182. The choice C is 102, but that is not the largest possible. So the correct answer is B, which is 182. It's a very nice problem using the property that the only even number, which is also prime, is 2. Okay, 15th problem. Let O be an odd whole number and let N be any whole number. Which of the following statements about the whole number O square plus N times O is always true? Okay, so O is an odd number. What happens when you square an odd number? Odd into odd. That is also going to be an odd number, isn't it? You can take an example and try it out. 5 times 5 is 25, which is also an odd number. So this is odd for sure. And then you have N times O. N times O. Now here N is just a whole number. It doesn't say whether it is even or odd. In fact, that is all given in the choices. Now let's consider both the possibilities. Let's say N is even. If N is even, what is even into odd? Even into odd. That's going to give you even. Right? So if this is N is even, then your answer is going to be even. I mean, the N times O is going to be even. If N is odd, then odd into odd is going to be odd. Okay. So this N times O has two possibilities. It can be even or odd, depending upon N. If N is even, this is even. If N is odd, N times O is odd. They are asking about the addition of these two. This is odd and plus this one. Now you have two possibilities. If N is even, your answer O square plus N into O is going to be odd plus even. If N is odd, your answer O square plus N times O is going to be odd plus odd. So this is odd plus even is odd, and odd plus odd is even. So if N is even, your answer is odd. If N is odd, your answer is even. Now you just have to see which choice matches with this observation. The only choice that matches is E. It is odd only if N is even. Only if N is even, or actually this one here, only if N is even, the answer can be odd. So the answer is E. Okay, 16th problem. The sides of a triangle have lengths 6.5, 10 and W, where W is a whole number. What is the smallest possible value of W? Okay, this is using the property of triangle. How do you form a triangle? Let's say you have a length here, A, and then you have another length, B. Okay, let's say this is P, Q, R. These are the 3 points. The distance between P and Q is A. The distance between Q and R is B. You want to form a triangle. You can form a triangle by lifting this point Q up. For example, if you lift the point Q up, what do you get? P, R, and Q is lifted up a little bit. Q. Now you form a triangle, isn't it? Now notice that once you lift it up, this PQ plus QR will always be longer than this, because this straight line here, direct straight line from P to R, is the shortest distance from P and R, from P to R. The moment you lift the Q, now the distance becomes more. So that means PQ plus QR will always be greater than PR, isn't it? This is the simple idea which tells us why two sides of a triangle adds up to always more than the third side. That's because to form a triangle, you have to lift that point Q above the line PR. The moment you lift it, the distance PQ plus QR will always be more than the distance PR, because PR is the shortest distance. PQ plus QR will always be longer than the direct path PR. So this, you can now move the points around and say the same thing for any two sides of a triangle, right? So that's why always any two sides of triangle adds up to more than the third side. Now using that idea here, you have one side as W. You can say that 6.5 plus 10 will definitely be greater than W. That means W is less than 16.5. That is one condition that has to be satisfied to form a triangle. The other one is, you can say 6.5 plus W must be greater than 10. That implies W must be greater than, I'm moving the 6.5 to the other side, W must be greater than 10 minus 6.5, which is 3.5. So what this tells us is the value for W has to be more than 3.5 but less than 16.5. It can take any value between 3.5 and 16.5. Okay, so between 3.5 and 16.5 on the number line, it can take any value. But notice that the W is a whole number. So that means it can only take whole number values, which is 4, 5, 6, 7, and so on, all the way up to 16. It cannot go more than 16.5. That means these are the values it can take. 4, 5, 6, 7, so on up to 16. What is the smallest possible value of W? The smallest possible value is 4, right? So the answer is B, 4. All right, let's go to the problem number 17. The shaded region in the figure below is formed by drawing two parallel line segments which connect the midpoints of the congruent squares. Congruent squares which are equal in size and shape. Identical squares. Each square has side length 1 centimeter. What is the area of the shaded region in square centimeter? Okay, let's grab this image and work with it. There are many shading problems. Most of them can be solved by simply moving the shaded region in such a way that you form a very nice image for which you can easily calculate the area. So in this diagram also, that trick works. You can take this piece. This is the midpoint of this square side, and this also is the midpoint of this side of the square that is given in the question. So if you take this, it will exactly fit here, because this also is the same length and this also is half the length. So it's going to exactly fit here. Same way, I can take this piece, which is shaded, and move it and fit it here, right? So now I got this center square completely shaded, right? It was missing two shades on the two corners, but now I moved those shaded portions into this. So this center square is completely shaded. What I have remaining is this piece here in the bottom, and there is one more shaded area here. Now these two, I can move this one here and put it like this. I can rotate it and put it here. So what is this small square. This is actually 1/4 of this bigger square, right? You can imagine that like this. So this entire area, after moving this shaded portion here, that is 1/4. And there is one full square in the middle. So there is one full square in the middle plus a 1/4. That is the total shaded area. They're asking in square centimeters. A square is 1 centimeter square, and this is 1/4 centimeter square. So answer is 1 plus 1/4 centimeter square. That is 5/4. If you convert this into mixed fraction, 5/4 centimeter square. That is the answer. The answer is B, 5/4. There are many problems in which you can use this trick of moving the shaded region and fitting it in so that you don't have to find out multiple areas. You can also go find out the area of all the shaded portion as it is, but that's a lot of work. So we can use this trick of moving things around, fitting it nicely so that you minimize the work and you get the answer much faster. Problem number 18. Okay, so here is again a mensuration problem, finding the area. We want to find out the area of the triangle BEF, and it's given E and F are the midpoints of the sides, and AB is equal to 2 centimeter. ABCD is a square. Again, let's grab this image and work with it. Okay, so this triangle BEF, how do we find the area of this triangle? What do you know about the area? We know that area of a triangle is given by half into base into height. If you know the base and the height of a triangle, you can find the area. But here, do we know the base and height? It's kind of hard to find. We can find maybe the base. We can call this EF as the base. Maybe we can find that out using Pythagoras theorem. But then how do you find out the height? The height would be a perpendicular line drawn from the base to the opposite vertex. And that is the height, the dotted line shown here. That is hard to do. So we're going to use some trick to find this out. You know the total square. The total square is 2 centimeter square because AB is 2 centimeter. And it is a square, so it is 4 centimeter square. Sorry, 4 centimeter. So this is 2 centimeter. All the sides are 2 centimeter because it's a square. The area of this big square ABCD is 4 centimeter square. Okay. Now, instead of finding the area of the triangle BEF, we can find out the area of the remaining portion, which is this triangle here, ABE, and this triangle here. Once you find the area of those triangles, you can subtract them from the total square area to get the center triangle area. The idea is quite simple like this. Let's say you have a rope. Okay. This rope is 10 centimeter long. Okay. You have a box and there is a hole in that box right in the top. And that same rope is put inside that, is put through that hole into that box, and now someone is asking you to find out what length of the rope is inside this box. What is this length? Like whatever is inside this portion. They're asking you to find out what is the length of the rope that is inside the box. You cannot see that, you cannot measure it because it's inside the box. How will you do this? You will measure what is outside, right? You will measure this length, the actual length like this, you will measure it. And let's say that comes out to be 6 centimeters. Then what do? You take 10 centimeter, the total length of the rope is 10 centimeter, and you are able to see 6 centimeter outside. That means 4 centimeters should be inside. So that's how you indirectly find out what you cannot directly compute. Right? You do the subtraction to find out. Same thing here. You want to find out the area of this triangle. That is hard to find out. You cannot directly easily find it out. So you know the total area. You find what is easy to find, these 3 triangles, and then you subtract it from that overall square area. Then you get the triangle area in the middle. So let's see these triangles. How do you find out half into base into height? So that is easy. This one is 1 centimeter. This is also 1 centimeter. So half into base into height, that is going to give you half a centimeter square. What about this ABE triangle? This is 1 centimeter. The base is 2 centimeters. So half into base into height, that's going to give you 1 centimeter square. Similarly, for this triangle BFC, you can take this as the base, which is 1 centimeter. Your height is 2 centimeters. So half into base into height is again 1 centimeter square. So the total area of these three triangles is 1 plus 1 plus half, that is 2.5. You're going to subtract that from the total area of the square, which is 4 centimeters square. 4 minus 2.5 is 1.5. That is 3 by 2. So 3 by 2 square centimeter is the area for the triangle. So the answer is D, 3 by 2. All right, we have two more problems to finish. 19 and 20. Let's do it. A square is divided into three congruent rectangles as shown. The middle one is removed and placed touching the others vertically as shown. If the perimeter of the square is S and the perimeter of the new figure is N, what is the value of S by N? It's a very interesting problem. Again, it's a mensuration. Now we have a square which is divided into three equal rectangles. That means we can take, without any loss of generality, we can take this as 3 centimeters. That means this also is 3 centimeters. Why did I choose the number 3? Because it is divided into 3 parts here. The drawing is not very good, but this is 1 centimeter, this is 1 centimeter, and this is 1 centimeter. Right? That's what is given in the question. It's divided into 3 congruent rectangles, identical rectangles. That means they should all have the same width. So because I know it is divided into 3, I took that overall as 3 centimeter for the square side. Then I get 1, 1, 1. I avoid fractions that way. Now the new shape is shown here. That centerpiece, the center rectangle is removed and it is made to stand touching these two sides like this. Okay. Now it's now easy to find out what is the perimeter of this new one. So this will be 1 centimeter, this will be 3 centimeters, this will be 3 centimeters, this will be 1 centimeter, this will be 3 centimeter, the top is also 3 centimeter, and this is 1 centimeter, this is 3, and this is 1. We just have to find out the overall perimeter. So we just add all the numbers that I have written here. 1, 1, 1, 1, that is 4, and then 1, 2, 3, 4. There are 5 3s, so that will be 15. Plus there are 4 1s, that will be 4, total is 19. Right? Did I miss anything? Yes. What about this portion here? That is also going to be 1. Right? So I have to add that. That's going to give me 20. Right? So I'm just taking the square to be 3 centimeters and removing one rectangle and putting it on the side. And I'm just adding all the sides for the perimeter and trying to find out the total perimeter. So the perimeter for the new shape is all these sides which I just added. Right. So by adding all these numbers, we get 20. What about the original square? Its perimeter will be 3, 3, 3, 3. Right? So that will be 12 centimeters. Now, what is the value of S over N? S is the original square, 12 centimeter. N is 20, the new one. So that's equal to 3 by 5. So the answer is A, 3 by 5. Now, you may be wondering why I took a specific value. Is it okay to take this specific value? Because that is not given in the question. Is it okay to assume certain things like that? It is okay because in this problem, we are trying to find out the relative perimeter between the two, right? We are not finding any absolute values. We are trying to find out what is the ratio. This is called ratio of the original square perimeter to the perimeter of the new shape. When you are comparing quantities, you can always make an assumption about one quantity. With respect to that, you will get the value for the other quantity, because they are going to be divided one by the other, it doesn't matter what is the absolute value, because we're not talking anything in absolute sense. So it is okay to take a certain value for one of them and compute the other one. If they are asking something different, what is the absolute value or anything else, then we cannot arbitrarily take it as 3 centimeter. We have to be careful there. But in this problem, there is nothing absolute in the question, so it's okay to take a value, give a particular value, and then find out the ratio S over N. All right, the last problem, problem number 20, that is, I think, probably the hardest one. That is again a shading problem, or like area problem. The diagram shows a large square. So given is a square, the large one is divided into squares of 3 different sizes. So they're saying there are only 3 unique squares in this diagram, apart from the larger one. What fraction of the large square is shaded? Again, we'll grab this image and work it out. All right. Now there is a certain pattern here that we need to understand. Now, how do you see how it is nicely fitting? This is the smallest square. It tells you that if you align 2 small squares, that's equal to that big square here. Right? This side and this side is equal to this total side of the bigger square. So if I'm going to call this as, say, 1, and this is 1, this is going to be 2. All right. If that is 2, then this big square here will also be 2. So that means from here to here, the total is 2 plus 2, that is 4. In that 4 units, you have 3 medium-sized square. So that means each one must be 4 by 3, 4 by 3, and 4 by 3. Right? So total is 4, and there are 3 medium-sized square fitting in that. So that means the side of each of those medium-sized squares must be 4 by 3. Okay. Now I think we are pretty much done here. We just have to now find out what is the total portion that is shaded. Again, it is fraction. So we are calling this as 1 unit without any loss of generality, and we're going to find out what is the overall fraction that is shaded. If we take this as 1 unit and we say this is 4 by this is 4, this is also going to be 4 by 3 because that is a medium-sized square, and this is also 4 by 3. Now I have to deal with all these fractions to get the answer. So one way to avoid fraction is you multiply all these numbers by 3, then you get rid of the denominator 3. So let me mark it in a different color. Just to avoid fractions, I'm going to do this. I'm going to take this as 3, this as 3, and this will become 6, and this will become 12. I'm just multiplying all the numbers by 3, okay? And then these guys will become 4, 4, 4, 4, and 4 here. Okay, now it's nice and easy. All the numbers are whole numbers. We just have to find out the total portion that is shaded. Now, what is this total length here? We just said that the medium-sized square is having 4 units as its side. So that means 1, 2, 3, 4, 5. There are 5 such squares, so this must be 20 units. Because it's a square, this also will be 20 units. So the total area is 400 square units. That is the big square, the overall big square. Now we have to find out how many of them are shaded in that. We can just start putting the fraction shaded is equal to 1, 2, 3, 4, 5, 6, 7, 8. There are 8 medium-sized squares, so I'm going to do 8 times the medium-sized square side is 4, and its area will be 4 square, that is 16, right? 4 square. There are 8 such medium-sized squares, so I calculate the area for all those which are shaded. Plus, now I have the two big squares here and here. We said it is 6 units, right? So the side is 6 units. So that means each one is 36 or 6 square. There are two such big squares. So 2 times 6 square plus the smallest squares, they are 3 units side. So each one will be 3 square units area. I have 1, 2, 3, 4 of them here. So 4 times 3 square. These are the shaded areas divided by the total area, which is 400 square units. So we just have to find this arithmetic. We have to do this and then get the answer. So what is this? That is 16 into 8, 128, plus what is this one? That is 36 into 2, that is 72, plus what is this one? This is 9 times 4, 36, divided by 400. Now we can add these two. Actually, it's nice and easy. You have 128 plus 2 will be 130, and then you have to add 70 because this is 72. You can break it into 2 plus 70. You give the 2 to this, it will become nice 130, and then you add the 70, so this becomes 200 plus 36 is 236. 236 divided by 400. Now just take a quick look at the answers. The choices are all having, most of them have 100 in the denominator. So that means to get 100 in the denominator, you have to divide by 4. Is the numerator divisible by 4? Yes, it is. The last two digits are divisible by 4. 4 9s are 36, so it is divisible by 4. So I will do the division by 4. 4 5s are 20, 36, the remainder is 3, 36. 4 9s are 36 divided by 100. So the answer is 59 by 100. That is choice B, 59 by 100. That's it. We solved all the problems. I hope you did well. And in case you have any questions, you can reach out to me. My WhatsApp number is 8825693. If you like this video, please give your comments. Thank you very much.